So we've previously looked at similar triangles, and with similar triangles, the sides are proportional. So if I had similar triangles, and if I had a smaller triangle, so poor sketches, but you get the idea. If this side were 5 and this side were 10, the scale factor would be 1 to 2. So then if this side were 6, this side would be 12. Basically, you're doubling every side to get from one triangle to the other. That's what it means to be proportional. That's what it means to be similar. Now, the exciting thing is that it's not just the sides that are proportional, it's all parts of a triangle. So it's the perimeter, it's the medians, it's the altitudes, it's angle bisectors, it's all these great things. So here we can see that the scale factor for this triangle is 5 to 3. Now, if we want to find the perimeter of this smaller triangle, what we would need to do is we would need to add up all the sides. Well, because I don't want to find the respective sides, the easier way is to realize that the perimeter is going to follow this same scale factor. So the perimeter of this larger triangle is 18. If you add up all the sides, you get 18. So this smaller one is x. I don't know what it is, so that's what I'm looking for. Right, so if we have 5 to 3 equals 18 to x. And so here we can cross multiply, and we get 5x equals 18 times 3, which is 54. And so that means that the perimeter of the smaller triangle is just 54/5. Again, leaving it as a fraction is okay. Here, same deal, and it even tells us that this triangle to the right has a perimeter of 15. So we can see that the scale factor is 6 to 5. So the perimeter is going to be 15 to x. So 6x is equal to 75, or x is equal to 75/6. Now 75 does have a factor of 3, so we can reduce that to x is equal to 25/2. Nice little proportion. You don't need to find the perimeter, you just need a scale factor and the perimeter of one triangle to find the perimeter of the other. Now again, other parts are also proportional. So here in this question number 5, we can see that we're given two sides, we need to find x. X is this altitude. We can remember that an altitude is a line segment that goes from a vertex of a triangle to the opposite side and intersects at 90 degrees. So if we're going from left to right, we get 6.5/13 equals x to 12. You're basically setting up this proportion as if it were just another side of the triangle. So we get 78 is equal to 13x, and we can divide that by 13, so we get that x is equal to 6. And it makes sense because 6.5 times 2 is 13, so 6 times 2 is going to be 12. Here we have a median, and the exact same principle holds true for medians. Medians cut a side in half, so it connects a midpoint of one side to the opposite vertex. So if we're going from left to right again, we get 16 to 12 equals 20 to x. 16 to 12 I can reduce by dividing both numbers by 4. So I get 4 to 3 equals 20 to x. Cross multiply to get 4x equals 60, or x is equal to 15. Now the next one is a little bit different. It's this here, we have this angle bisector, but we're not looking at the length. Instead, what we're looking at is one triangle and the relationship of the sides with this side cut into portions. So what we could do is we could say 18 to 24 holds the same proportion as x to 9. So these two sides that aren't sliced up by the angle bisector, we can set a proportion with those two numbers, and that's going to equal the two parts of the other side. So again, 18 and 24 have a common factor of 3, So we get 6 to 8. Sorry, they do have a common factor of 6, don't they? So you don't have to reduce. It makes the multiplication so much easier, though, because they both have a common factor of 6. So this becomes 3 to 4 equals x to 9. Cross multiply to get 27 is equal to 4x. So x is equal to 27 over 4. And that's it. So again, get lots of practice, work your best through these problems. But remember, so much more follows that similar scale factor proportion than just the sides.